Hey, yeah, I just got the sound muted while I was setting up. Welcome in. We should be carrying on and finishing, hopefully, this PC Engine GT now. We haven't got that much left on it. So we've got this now. I've finally fetched the audio amp here and the audio connector I've chucked on. So these are brand new ones. So you can see nice and clean now. And what I'll do, I'll just remove that from the customer's board just so we don't get confused and think we forgot something. You should have audio now as well, by the way. I got it muted at the start, but you should hear it now. So that's all that side we did yesterday. I've just started this side. So all I've done is the diode, and then we got stuck on this Q200 package. So this took a while to identify. I'll go through how I've identified. I've got the exact part number now. When we come to Q201, we're going to have to do exactly the same. So I'm going to leave that for now, and we'll circle back and I'll show you how we identify that package and figure out what it is. Same with Q504. We're probably going to have to do a similar thing on that. So we'll do all the other components first and then go back to the more complicated ones. So we'll start with Q202, which is a 332 resistor. So that should be 3.3K. Yep, and that one is. Hey, yeah, no problem. I've had a few emails about the GBCs today. Is it the... were you working on a few consoles with the GBCs? And having issues with Eneloops, was it? Or was it somebody else with... I can't remember what the other one was, but I remember answering one recently about the Eneloop batteries. Nicer. Yeah, I've jumped on a bit late today. Mondays are manic with orders though, so not usually going to be on early. Yeah, restoration of a GBC. Yeah, we get it. We get about probably 80. I'd say about 80 emails a day on average. So I've had quite a few GBCs today. I can't remember the GBC with mods though. You'd have to refresh my memory on that one. We've got C200. We'll do the other resistor first. R512. And that is 1, 2, 3. So that'll be 12K, will it? I think. Yep, 12K. Yeah, on a Monday I'll sometimes be on early, but usually Mondays are too busy with orders and packing, so most other days I'll be on in the early morning. C512 is 12K. Right, now we'll do the caps. So we've got cap C512. Nice. Yeah, I've got a Halo edition. Have you done the Halo edition 360 yet on the RGH? I'm about to do one, but I've got a feeling it's going to lose the custom boot up sound because that's stored in the EEPROM, and I think you can mess with it and back up the sound and restore the sound and stuff. But I don't know how far I want to go to do that. But I don't know that you've done the Halo ones before to know if that's actually going to wipe the sound. I'm pretty sure it will. But it might not. It might patch the existing one. Ah, nice. So yeah, sound's going to remain. That's good then, because I think I had a customer before that didn't want it in case they lost the sound and I wasn't sure. So that's good. This is reading 30 nanofarad. Not exactly standard again. Let's have a look at what standard values are near that. I should really save this image. Standard capacitor values. I'm going to save this list this time. Or at least bookmark it. Add. I'll do it in a minute. Right, so nanofarad wasn't it? Yeah. Oh, there is a 30 nanofarad standard, so it might well be 30 nanofarad. So we'll write that down. C512, 30 nanofarad. Ever made anything with ESP32s? Yeah, I tend to use the Raspberry Pis instead, like the RP2350. I prefer that over the ESPs. They're more powerful, but I prefer the Raspberry Pis at the minute. I'll probably move to ESP32s at some point, but I just prefer the PIO system in the Raspberry Pis. It's more powerful than the ESP. You can do a bit more with it. So it's a bit closer to like FPGA stuff without having to need an FPGA. Hey, welcome in. Thanks for enjoying the streams. How do we know the specs on the components? We're measuring them all, so we're putting them all through a one is an LCR meter, so this will measure inductors, caps, and resistors accurate. Another is a component tester, which will test and look for common components, transistors, diodes, things like that. So, and then a bit of knowledge searching for stuff on the ones that are like 6-pin that you can't really just put through a component tester. You have to use a bit of investigative work to figure out what's going on. You'd think so with the Raspberry Pis, but they're not actually. The documentation is pretty lacking, to be honest, on the C++ side. So a lot of the things you only find out by looking at the source code. I think it's getting better, but yeah, the documentation's still pretty lacking, to be honest, to what you think it'd be. Right, where are we now? We've done that cap, we'll do this cap, and then I'll probably show you how to identify this Q210. Why not? Where's it gone? Board's in the wrong orientation. There we go. Got each board in a different rotation. Using a multimeter for just the diode checks, I probably use the multimeter for. Otherwise, the LCR meter is more accurate. So I'm just really using that for when I see a diode package that's like a dual diode package. I was using the component tester for dual diodes for a little while till I clicked in. I was just being an idiot. I don't know why I was using that for identify diodes. I think I just got used to using it. 100 picofarad, that one's measuring. Seems fairly stable. Yeah, 100 picofarad both times, and that is a standard value. So C200 is 100 picofarad. Feels like we've been on this transplant for forever, but there should be the last stream now to get this all done, I'm hoping, like all the transfer work over. Yeah, I think a lot of it with I think most hardware, to be honest, most anything to do with hardware, FPGAs are even worse. They tend to be just terrible at documenting. It's just fairly common in the industry. I think the hardest part of hardware design and the hardware / software integration stuff is literally bad documentation. It's really poor. It has been with everything I've used, not just the Raspberry Pi. It's pretty bad across the board for some reason. It's better than it was, but it's still not great. I'll chuck C513 on, and then we will do the identifying of Q200, which I haven't done yet, but if it's similar to Q200, I've gone through all the legwork of figuring that out. It should be a fairly similar process, so we shouldn't struggle, hopefully. So move him to the side, let him cool off, and then we will use this LCR meter if people wonder what's going on when I'm just touching these probes on and you can't see what's going on. We're basically just touching these either side of the cap and waiting for it to read a value. And that's reading 150 nanofarad, which again is pretty standard, and we've seen that a few times on this board, so it's very likely going to be that. So C513 is likely 150 nano, did we say? I'm terrible at remembering these values in between writing them down. Yeah, 150 nanofarad, so that's that one. Oh yeah, I've been there with the diagnosing stuff. What was I diagnosing the other? Oh yeah, that was a classic one. We were diagnosing a Sega Saturn a few years ago. This was an absolute corker, and I hadn't worked on it yet, but we'd had a guy that worked for me at the time, Martin, working on it. Zach had worked on it. Basically try and get a Sega Saturn reading discs. We've been on it for hours. Realised we were using a Mega CD disc for testing the Sega Saturn, so it was never going to work. Hey, welcome into the chat. Yeah, the Atari Clean Comp is one of my favourite designs. That was what taught me all about. Well, I taught myself effectively all about composite video signals, and then that led on to RGB and stuff. So the kind of part of the reason I wanted to make the Clean Comp for the Atari, it was the first Clean Comp, was to really understand what composite video was made of and prove that the knowledge I'd learned was accurate by actually reconstructing composite video from scratch. So that's what the Clean Comp does. It literally remakes the composite signal from the TIA pins, and I put a lot of work into that. There's many revisions of that board, but I figured we've got now, I think, the nicest composite output on an Atari 2600 that anyone's seen. And then that led me down the RGB route. How much for having the work set up? What, as in like equipment, you mean? Like what's on my bench? Well, we've got this fancy camera, so I've got way more than what's on my bench, but we've got oscilloscope down there. That's my most common picoscope, like I don't know which model it is, I've got that many of them. Hot air station above, obviously a little test speaker there, batteries, a couple of games. These are super high powered lights, so they are used when I'm using the microscope, which I rarely use now. Soldering iron here. This is a cleaner for the tip, so just got rollers inside to really clean the tip. That costs more than the soldering iron. We've got a little rusty figure that somebody made for me. One of my friends from years ago made that by hand. We've got the tank from the Neo Geo, the what's the name of the tank? I always forget, but he's 3D printed and hand painted that. That's wicked. I really enjoyed it. So he's lived on my desk since. Component tester obviously there. We've got the LCR meter out. Got my extractor fan I never use and everybody tells me off for. This is all camera. This is me pull focus for the camera. A little zoom in button for the camera. Another light from the other side. Over here that you don't really see so much because the camera itself's in the way. But over there you can just glance in the corner maybe. I don't know if I can even get that in focus because the camera's on there. I can't really show you because it's literally where the camera's pointing at, but there's stuff here which you can't even see. Right in the corner over here is a bunch of power supplies and signal generators, electronic loads, all the advanced stuff that you don't see much of. Tools on my desk, so I've got cutters there, wire, solder, and so solder and wire here, so I'll just reel it off on this side. A bunch of screwdrivers in, obviously, Jurassic Park cups. So this has all like the common tools, scissors, screwdrivers, marker pens, grinders. Got 3 or 4 cups over there with everything in. We've got walls, got CRT here. Got walls and walls of connectors for all the consoles. Zach's desk over there, which is a shit tip at the minute because it's in the middle of stuff. Keep going around. We've got more walls of stuff here, which that is as far as that wants to go that way. I'd have to spin all the way around the other way. Customers stuff here. So this is all customers' goods in, basically. Boxes and boxes full. There's the Doom chair. That's my LCR meter beeping at me. And then under my feet and everywhere else, I've got tons more tools. Thermal cameras, equipment everywhere. But generally, I keep on my desk what I'm using all the time, basically. For those that don't know what we're on a PC Engine, customer's PC Engine that we're fixing up, swapping all the components over between these 2 boards. And this is a board I've made that's basically a clone of this one. So hopefully it'll work when we've done that. And we were about to identify this component next in a second, this Q200 or Q201 will identify in a minute. So this is what we've got to figure out. Started in electronics years ago, just desire for myself to make a product for trailers to find blind spots of cars. Using flux, I do, but when I'm doing these soldering, I use SteriFlux. You'll just see me blob a little bit of solder on the whiteboard before I reflow it. Oh yeah, cost is 100 to 200,000, I'd say, and stuff I've got easily, if not more. I've got some machines and equipment, 20 grand, 25 grand. I've got a thermal camera that's 25 grand. The camera above me head's 10 grand. Yeah, there's an absolute insane amount of money in the equipment. A lot of what I use isn't expensive, but I've got some ridiculous amounts of money invested in it. This one then, we want to identify. What I've done for this, I've already done this to try and figure out what Q200 was. So we had a 6-pin chip here. And obviously, because the component tester's got 3 pins, you can only really test 3-pin devices. We have a 6-pin device here. So the first thing is you could sort of Google and search around for 5C09 or whatever this is, but typically on packages, the smaller numbers here are like date codes and manufacturing codes and things like that. So you won't get anywhere with that. You'd want to focus on a 5C. And then when you're looking for packages, you want to get the package size. So I've measured this with vernier to find out the exact size. It's identical to this. So this one I've found out is a SOT, wrote it down, I think it's a SOT 23-6, yeah. So it's an SOT 23-6, that's the package size. So then we could Google SOT 23-6 package and then 5C and see where you get. You won't get that far with it, but one thing you will find is because we have a designate here, these indicate typically what things are. So C is capacitor, R is resistor, Al is for inductance because the Al is the inductance. Q is typically transistors, D is diodes. So we have a big clue here, and this is how we figure out what it is. The Q is almost definitely meaning it's transistors. Now transistors are 3-pin, this is 6-pin. So the likelihood is, it can be different variations, but your most likelihood is this is going to be 2 transistors in one package. So then we can narrow down the search and search for a dual transistor SOT 23-6 and then 5C tagged at the end. That'll get you just results because there are dual transistors in a package. It doesn't really get us the answer. So then what I did further than that was there's websites you can find that are called like SMD marking identifiers, and these codes 5C and I think the other one's 5H or things like that, the semi-common package indicators. And if you search enough, it took me a while, but I found a site where it says that basically the 5C marking is very typically a I think it said, it got it wrong anyway, but it said the 5C is typically a NPN transistor, and the 5H, which is already on here, is typically a PNP transistor. Now, once it gave me enough clues to figure out, right, this is likely 2 transistors in one package, I put randomly 3 pins through this component tester. So I just soldered on wires in random orientations onto 3 out of the 6 pins until I got a hit. The first one was a diode, the next one was a resistor, and then the third one it went out, it's an NPN transistor. So I found that I believe it was pins 3, 4, and 5 showed up as an NPN transistor. So then after that, I could solder wires to these 3, and that showed up as an NPN transistor. So then I knew it was a package, a dual package with 2 NPN transistors in a layout. Then I hunted DigiKey and managed to find an exact part number to replace that. So we're going to attempt the same thing with this now. So let's do exactly what I did on the other package, because this isn't the same. So we're still going to have to identify it, but we're going to use the knowledge from the last one to figure out hopefully what this is. And my thought is, if the 5H was an NPN, I'm going to already make the assumption that a 5C is a PNP, so the opposite way around, because the marking is different for a reason. So I'm going to make the assumption that we're dealing with the same pinout and the opposite transistor. So this shouldn't be hard at all. We should be able to do this fairly quickly because I'm making a lot of presumptions that this is very similar to the one I've just done. So what I'm going to do is put this on here. So I've purposely soldered one of the wires to here so that this is now fixed. You can see it's not very strong, so I've still got to be very delicate when I'm doing this. But it's secured enough that I can attach some wires. So now I'm going to take this component tester, and I'm going to take these leads, the 3 flying leads, and solder them on. And I'm going to solder them on this time in the same order as I did for the other package, because I'm going to presume it's the same. That's pretty much the logic. I've now got some reference point to say what it is. Yeah, Darlington pair, it could be, but it isn't. In the case of the other one, it isn't. This one might be, in which case it's going to be 2 transistors with a resistor in there stacked to amplify the gain up to like 1,000 instead of 100. This, though, I think is just going to be literally 2 transistors in one package. So I think we're going to go pin 1 here, pin 2 here, pin 3 here. Based on that's what we did on the last one. That's the combination I found worked, basically. So we just need the leg tacked on there very delicately. Pin 2 is the red one, so I'm going to go with this leg on here. And then pin 3 is this leg over here. I can just about see it with the zoomed in, really zoomed in lens. I can just about get this. It's I'm working off the image you guys can see here, so pretty hard to see. And I've got a tip the size of England. There we go. So with that on now, what we can do is zoom out a little bit so you guys can see this. I don't want to bend the pins too much. There we go. I'm going to tap this and hope for the best. This should be, I presume, a PNP. Yeah, there we go. So basically all the work I did on the previous ones paid off on this one. So now what I need to do is make notes of this. So we have the, what is the package? Where did it come from? Q201. Q201. It's going to be a dual PNP BJT. The marking is NC, and I'll find the part number after. Hopefully the next hunt is we'll find a part number for it. We have a VBE afternoon rhyme, welcome in. VBE of 0.8, I'm going to say that's meant to be 0.7. It's just a worn out component. 0.7 is a fairly common volt drop, or rather saturation voltage for the base. Pin 1 then is actually pin 3 on the package, where we've got the wire soldered. So the collector is pin 3, so I'm just going to put pin 1 equals, and I'm going to leave that blank, 2 equals 3 equals, right. So now pin 3 is, and you can see me just putting it on the spreadsheet here, basically. I'm just starting to type. Pin 3 on the package is pin 1 on here, so that's the collector. And I'm going to put it in as the collector 1, and then pin 4 is the next pin on here, which is pin 2 on here. So pin 4 is E. So 4 equals E, and it's going to be the first collector. Pin 5 is the one above, which is going to be the base. So pin 5 is the base 1. And you can see on the one above here, it's exactly the same layout. So it's literally pin 3 is collector, 4 is emitter, 5 is base. So I'm going to already fill this out, presuming the other pins are identical, and then we'll test that they are. So we should be able to find a complementary pair based on the part number I've already found. So you can see I've already found this part number that's a perfect match for the other one, MMBT3904DW. So I should be able to find the PNP variant of that exact make and get the code. So just before we do that, let's confirm the other pins are right, because I'm just making a presumption, like I say. So gently move this back into position. Zoom right in as far as we can go. And now what we want to do for this one is we'll take the wires off. And then because we now want to test the top 3 pins, we will move this off there and up to the top. I don't know whether that's fully in focus and it's just the zoom. Yeah, it's pretty much the lighting on this. because of just the sheer tiny size of this component. You can't really get any clearer than that at the minute. So now we will reattach the top wire. We're not building a computer as such now. This is a PC Engine GT, and this is for a customer, but at the minute we're identifying what each component is on the circuit. So this is like a identifying components basically. So pin 1 is there, pin 2 is the next one down. So pin 1 and 2 in this case will actually be pin 1 and 2 on the tester as well as the package. It's there, and you try not to put any strain on these pins because they're super delicate. And then pin 3 is now this top pin that was originally anchored to the board. And that's anchored on enough for ours. We only need it to test, which should be good enough. So now do that, bring this down gently. Oh, he says gently and pulls the wire off. Let me just reattach him. And it's only the solder that's come off there, just a dry joint. It hasn't done any damage to the package. Just reattach these. Bring it down again. Let's try not to snap them off this time. There we go. And now this should say the same thing, hopefully, a PNP transistor. Oh, an NPN. So this has actually got an NPN and a PNP. Now, we definitely saw a PNP the last time, didn't we? Just so I'm not getting crazy, which means this might be a Darlington. This might actually be set up as, we'd have to test if any pins have continuity between them in a minute. But more than likely, this is just a package with a single NPN and a single PNP still. But let's see. If anyone remembers if that was definitely PNP on the last one, then let me know. Otherwise, I might just double check it. Now this one's actually an NPN, but I'm sure it was. So I'm going to write down, instead of C2, I'm going to put C PNP, B PNP, and E PNP. So this will be pin 4, pin 5, and pin 3, wasn't it? So that's the P. And then pin 1, 2, and 6 are the N. I'll double check that other one. It'd be strange if it was, because it's got a different marking. So that's why I'm thinking it's not, but that's now the N setup. And let's just double check. So 1 should be the emitter to the base. Yeah, 1 the emitter to the base. See that. So that's all the same. So let's just swap back, just to be sure now that it was a PNP on the other pins. Because that's got me wondering. I'm 99% sure it was PNP, but let's just double check. Move this back down. So this one is going on pin 3. Next one, pin 4. And the last one, pin 5, just to double check. And then, do we have now a PNP transistor? Yeah, we do. So we've double checked everything's the same. Pin 3 is collector, which is right. Pin 4 should be emitter, which is right because it's number 2. Pin 6 is number 3 on there, which is the base. Yes. 3, 4, and 5. 3, 4, 5 as the base. Yeah, so it's all right. But now we have in here, this package, we've got a combined PNP and NPN in one package. So given that we already have a part number for the other one, I'm going to see if I can find anything related to it. I might search now, I might search later on, and then let you know. I might do as we're talking through the stream, just to start hunting, because I don't want you to sit here while I just search for a component basically. But I'll do a hunt with all that information we've now got, and we should be able to find the exact part for that. We know the pinouts, we know what's in there. They're basically just a dual transistor package, so I'm sure we'll be able to find a perfect replacement for that if we look. What's this thing do for the customer? It's basically a handheld console. I'll show you in a second. It's like you can think of it like a Game Gear or a Game Boy. So it's basically a much rarer but handheld gaming device. This one's obviously got no buttons in at the minute, and it's all non-functional. So this is the original circuit board. You can see we're gutting all the components off it, swapping them over to this board, which I've made basically completely cloned the original board, so that when it's got rot and damage, we can repair them. And then as we're transferring the components over, I'm just identifying them at the same time. On this as well, the PC Engine, pin 1 is identified by this kind of rectangle here. So we just have to make sure on the chip, you can quite easily see that reflective dot. So that reflective dot needs to be up against this L shape in the corner. And there you can see that 5C marking quite easily now. What kind of wire do I use? You probably call it enamel wire or magnet wire. It's basically about 0.2 mil thick wire, and this red is enamel coating. You typically get it in, let me see if I've got another tub that's more standard. See what I've got in the spare. So you normally get it in a reel like this. Yeah, wrapping wire is another name for it as well. So you can see this one's had a puncture, but just again, magnet wire. And it normally comes like this, looking like copper. So when I was using this, I'd be constantly stopping telling people when they were saying, why are you using bare wire? You're going to be shorting things out. So obviously, you'd expect that in one way, because it does look like bare copper. But I got a bit tired of constantly telling people it's enameled wire and there's even invisible enamel on there. So I brought red enamel, just so people don't get confused when they're watching it. They don't think it's bare wire, basically. And yeah, it's insulated. That's what the enamel side of enamel wire, the red is the enamel, basically, which acts as an insulator. direct connection from a mobile phone screen flex to a HDMI. Possibly. They normally use what's called DSI, or I think it's DSI, like MIPI, basically. MIPI DSI, which is a standard for integrated screens. So it's not technically HDMI, but you can get MIPI to HDMI converters. I doubt you'd get a direct cable. In essence, it would have stuff integrated into it. I think that's all the questions. I don't think I've missed anything. Right, so we will, I'll tell you what, give me a couple of seconds. Let me see if I can identify this package, because now I know what the other one is. I'm wondering whether I can find it fairly easily. So we have a PNP on pins. The PNP was pins 4, 5. So 1, 2, 3, 4, and 5. So 1, 2. 1, 2, and 6 with the NPN. Just fix me notes a minute as well. 1, 2, and 6 with the NPN. 3, 4, and 5. That's it. So pins 3 was collector. Pin 4 emitter. Pin 5 base, and then NPN on pins 1 emitter, pin 5 base, and pin 6 collector. I'm just going to do a quick search, see if I can find anything. Hey, thanks. I'm glad you're liking the teardown. And no, I am not sleeping. It's only, I'd be in trouble if I was sleeping. It's 5 o'clock in the afternoon here. Right, they might share pin 5, maybe. I'm wondering if this is a complementary pair. So basically like a Darlington in this case. Let me see if I can find this. Potential part number. NPN, PNP, SOT 20. Ooh, that's expensive if it is. I could probably find some cheaper alternatives. Show me. Oh, I hate it when they don't show you inside the package as a nice layout. I wanted that to show me inside. C1. Yeah, so I don't think. Actually, this might be it. Yeah, I think I found it. So let's just look at that. Oh, where's it gone? Where the hell's it gone? Over there. Right, so this is the package I think it is. Let's pull up the screen. So after a little bit of hunting, that wasn't hard at all. We've pretty much guessed it because we kind of know what these components are. I'm guessing it's basically an NPN plus PNP combo, so that's what I've searched for in DigiKey. I've hunted for filtering by the exact pins we know, and this then instantly matches. It's about the only one I can find matching, and it's crazy expensive, but now we know it, I can source in the factories in China. I'll be able to source a replacement for this super cheap. It's the right package size. Now all we've got to confirm is this pin and layout here. So these pins here, and we had on ours we've got an NPN on pin 1 is the emitter. So NPN there, pin 1 is the emitter. So if we flipped it round, E2 This might not be. I think it's actually right if we flipped it around. So we have the PNP on E2. So E2 is the PNP based on the symbols. Yeah, so if we rotated this 180 degrees and classed this as pin 1, would that match? I don't think it's actually matching the pinout. No, it isn't, is it? Emitter, pin 1. Oh, it is. Emitter on pin 1. But that is the NPN, whereas this is the PNP. So if you rotate it round, though, pin 1, 2, 3, pin 4 would be emitter. Yeah, so pin 4 would be the emitter of the P. It's confusing going this way. Pin 5 would be the base of P, which it is. 1, 2, 3. Pin 6 would be the emitter of N. No, so it's not quite right. It doesn't quite match the pinout, but I do read chat, yeah, when I'm not turning my head sideways. So I almost found the correct one there, but that's basically what I'm going to do. I'm going to search for complementary pair NPN and PNP BJT transistors in that package, and I'll just scroll DigiKey and look at datasheets blindly, and I'll find one fairly quick. And I don't want to bore you with that side of it, but you get the idea now. I think you'll realise that's how I'm going to figure out what that component, like we know what the component is now, but that's how I'm going to figure out finding a new part number, basically. So now we can put these connectors on now because we've done the other side of the board. So let's just show you how to do one of these. Pretty simple. Solder on there, flux on there, and we're going to warm this from the other side of the board because we don't want to melt it, and we don't have spares, and you can't buy spares at the minute until I find out what they are. So this is the customer's original, and this is probably going to be hardish to film. Zoom right out. What we need is, or what I need something to hold the boards up here. I originally did have a little arm gripper, so I'd almost want to have this up here like this and have a little arm. What I'll do is I'll buy a little, what are those things that used to be like they wrap around tree branches, the little camera grip arms, but I want it with a claw at the end. I'll figure something out for that. Until then, what's a low-tech way of holding this board here? So you can actually see that. I want you to kind of see the melting there while I can get my hot air under it. So I sort of need to hold this here somehow. I know the lo-fi way, just hold it with my hand, I guess. So if I turn it that way so I don't melt the skin off my hand when I do this, we'll zoom right in so you can see. And now I'm going to attempt, you can see what I'm going to attempt here, because I'll go to this camera. So I'm holding this in midair. I'm going to get this like this. I'm going to aim this underneath like this, and I'm going to kind of treat it like a hot plate, do this, and try to look at the camera while I'm doing this. So this is going to be fun. Get that into focus for you. Get this underneath, and I could probably do with focusing that now. It's a bit lower. There. Get that in. The things you do so you can see it happening. So right, there we go. I can't move the hot air because it's the wrong hand. So I'm going to move the board instead of the hot air. Otherwise, we're going to get heat in one spot. Which is, well, I'll try and move the hot air, otherwise it's not as nice looking. This is burning my finger already. So what we're looking for is when that melts, it'll just pull into position, hopefully. I'd normally position with tweezers and stuff, but I've got no third hand. So, this is really getting hot on the finger. Nearly there. Ow, 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 hot, hot, hot. Can't be far off now because I've got no skin left on my finger. There we go, see the bubbling starting, and this should pull into position any second now. Come on, pull into position. There we go. So the solder's melting. Can I shake it into position? Oh man. I think that's in position. He wants a slight nudge. Are we? Yeah, we're still molten enough to nudge it. There we go. That didn't hurt my fingers at all. So you didn't really see a nudge. I kind of wanted it to pull into position, but you can see it's not melted anything. The connector's nice and good. All completely clean, and that's soldered on. So we'll just let that cool a minute, and then we'll clean that flux off. We'll place them back down. I definitely need a little gripper to do that. So when I'm doing that next time, look at how red that finger is. That's been taking the brunt of that heat the whole time. I think that nail has melted. That was I was hot. I was just about on the verge of not bearable. Come on, yellow, get out of the connector. That's going to make me warm it up, isn't it, to get rid of that yellow. See if I can just get scrapers in between there. I think that's some original flux in there, that yellow, not ours. I think that's come off the original board, because ours cleans up quite easy. Well, that will probably come off. There we go, it's nearly off. I was going to say that will come off when I do a final clean on this board. Yeah, that's that one. Streamlabs, I forgot to set that up. I set up Streamlabs to tell everybody to buy Rusty a treat every 20 minutes or something, or after 20 minutes. Yeah, I could solder directly on the pins, but I much prefer hot air. But it wouldn't be hard to solder that by pins, to be honest. I'll do these two after, but I won't bother holding that and, you know, getting it in a funky angle. I'll just do it over the edge of the desk like I normally would. You just won't be able to see it very easy. Oh yeah, the batteries, it's the same for the Game Gear. The batteries used to get drained by them. Whereas now, funnily enough, the clean screen is lower power than the original screen. Plus then the Clean Juice adds a ton of power, so you can actually now do a 24-hour gameplay on the Game Gear using the clean screen and the Clean Juice. People keep asking for it for this PC Engine, so I'll probably make a similar thing like a AA rechargeable battery pack and screen mod for this at some point, so that you can get longer gameplay and you don't have to keep buying batteries. Q504, I'm probably going to skip for now identifying as well until last, because that one's going to be a little bit harder to identify. Right, I wrote down all of those designators, so now we'll do R511 here, I think, first. Well, we'll do all the resistors again. 510, 511, and then the array of 203 rather. So let's just pretend these pads on this board, identify them on the other and test them, and then hot air them all over in one go. That's that all clean. So now if we go over to the customer's board, we want to measure the 511, say first, and if we zoom right in, 511, oh yay, that's going to be, I'm guessing 681, so that'll be 680. 682 will be 6.8K. So I'm guessing it's going to be 680 and 6.8K. That's the assumption. I should probably keep my multimeter this side of the bench now, because with doing the streams, I'm always moving this back over. I've got a slimmer iron coming soon, so I'll probably put my multimeter over this side so I can easily bring it into view. So 680, I think we said this is. Yeah, 680. So 6.9K basically, which is the 680. And the other one then will be 6.8K. Yeah, so those two are fine. We'll swap them over. I thought we were getting nice and close on this, and then we've got a ton, a ton of bloody components that are going to be fun to identify. We've got like another queue up here, so I'm hoping it's not going to be too hard. Where are we? We've got like the Q503 here. We've got a Q501 here. We've got a Q902 here. The transistors won't be hard. We've got the Q504. Bunch of component testery stuff we're going to have to do. But we're not that far off now. So we'll hot air these over in one go. So I'm just going to hot air them off, place them on the table in a similar layout so I don't get them mixed up. And we didn't identify these, but we'll test this one on the board when we swapped it over. It's a resistor pack, so I'll remember to measure that in a second. Over here, extra flux. How do I identify components are linked up, as in where they go? I've done PCB scans of this entire board. That's how I've remade the board. So you literally use your eye and follow all the traces where they all go to, and you draw up a schematic very slowly to figure out where everything goes. That is effectively the reverse engineering side of things. So it's something I will do once we've identified all the components. I'll redraw the schematic fully as well. And then we have a complete remake, including schematic of this entire system then, which I don't believe anyone's done. And I believe there's a few people that seem to have done it partially, but they haven't identified all the components, and there's quite a lot of mistakes I've already seen in anything that already exists out there. In attempts to reverse engineer this, I can already tell you that the existing ones out there are wrong in not tons of places, but enough places that they're not accurate enough to rely on, basically. If you want to draw it out yourself, then is that on? I think we've got some discoloration on the edge of this board. Oh, that's a shame. It might clean out, but surely that's going to clean out. I think we just got like a flux stain somehow. See that little bit of yellow there? And then on the other side, just a little tarnish of yellow. I'm hoping that'll wash out when we do a deep clean of this after. That's kind of annoying because everything else is perfectly white. And I can't see that being burn as such because we've hot aired a lot more places with a lot more heat than there. So let's hope that isn't a little burn. Yeah, I will be up the road. I'm on Bagnall Bank. Oh yeah, the TikTok, to be honest, TikTok's really good for me. It does advertise. I think everybody in Stoke knows me on TikTok. People I don't even speak to know that I'm on TikTok, so it obviously does a very good job of pushing me locally, that's for sure. Right, so this resistor pack we need to identify. If we zoom in, that looks like 151 to me. So that's going to be 150 ohm, I'd say. So I get the multimeter on them. We need to check every one as well because we are obviously transferring them over to this board. So I need to make sure for the customer's sake, all these are good. Yep, 150. 150, well, 155, but close enough. 155. 155, so they're good, and that's 150 ohm. We are fixing this PC Engine GT for a customer. Basically a handheld, transferring it over. So this is the customer's board, transferring it over to our new board and identifying every component as we go. So at the minute, I'm just in the middle of identifying all the components. I think we've got some resistors reversed. Let's have a quick look. No. Top one is the 6.8 and the bottom one is the 6.8.2. That's the way they were on, unless I'm mistaken. I'm 99% sure that was the way those two were on. I've also got a document that a guy that was watching the stream the other day sent me, where he's measured components as well. So let me just quickly check what he wrote down as a double check, see if it matches that. So R510 he's got written down as, 6.8K. So they look like they're the right way around. So we have R510, 6.8K, R511, 680 ohm, R203 was 150R times 4. We've got a capacitor next, C210, C201. How much is it going to cost the customer? They've paid, I think, 350 quid for the board swap and a TFT upgrade. So we've got to do a full TFT upgrade yet, an IPS screen. So this board will give it a brand new screen, so he's paid for that as well. But he hasn't paid for diagnostics. So the bulk of the cost, the screen's like 100 and something pounds install. The basic fee is 40 odd pounds, I think. And then the re-PCB is probably the other 100 and something, I'm guessing, due to the fact of simply how long it takes. It takes a hell of a long time to transfer everything over. Right, C201. The NES pin video. I've done quite a few of them. I think that they definitely work better than replacing the connectors. If you just service the original connectors well, I think it works a lot better than swapping them out at the minute for those third-party ones. So that's to the side, and then we'll measure this. So let's see what this is. Oh yeah, this has been a long process. Like a lot of this, like I say, is not what it'd normally cost in terms of time wise. It still costs the same monetary wise to do this one, but my time is obviously I'm spending it all identifying these components. So it wouldn't normally take me 12 hours. The board swap would probably take me a few hours at most, and then obviously you've got the cost of the board and the fact you're paying for keeping a business going, customer service. It's not just material cost and hourly rate. It's to keep a business established and allow us to do what we're doing and allow us to offer customer service and all that kind of stuff. You can always go to other people if you want things doing cheaper as well. We're not going to be the cheapest, and we never will be. I do this for pleasure, and it needs to be something that I enjoy and I can spend the time doing and not rush. And I'm not in it for penny pinching either, like making not in it to make a killing, but I'm also not in it to work for free, if you know what I mean. So I just charge what I feel is acceptable for my skill level and time, and that's what I've done for years. And we're literally 100 consoles deep constantly, so obviously we're doing something right. This one is going to be a 68 picofarad. That's the next closest standard size. It was measuring 63, and a standard size is 68 pica. So that's what that one's done. All this is open source. So if you go to retro6.wiki, I can show you this. This is another thing that costs me money, which is ironic. I give away my knowledge for free, and I have to pay like 50-60 pounds hosting this, and it was more than that, plus the upkeep, plus my time writing it. So there's a little donate button here, which I think just goes to PayPal, but I've changed that now, or I will change that. I'll probably change that today to go to this integrated Streamlabs, and then there's like a /retro6. So this is kind of the new little page if you wanted to donate anything for my work, and it's just all integrated in one place. And then if people tip, it fills up this meter on stream above there where it says Rusty's Bed Funds. But yeah, this is all free. I give it away, but it's cost me thousands over the years to host. Absolutely mountains of info. So if you went to PC Engine GT, you can go into it. You've got schematics, you've got board scan. This is the one that I've destroyed myself, brought one for £600, gutted it, stripped all the layers out, scanned all these, and that's how I've remade the PCB. There's a little board viewer here if you wanted to. This is where I said if you want to reverse engineer where the pins go, for that person that's really interested in doing that, you can use this and literally visually track everything. You can just scroll through, draw it, and make a schematic from this. That's something I plan to do when I get the time. Like, obviously, we're in the middle of figuring out the bill of materials at the moment, so we haven't got time to do the other side of it. But if you go into this interactive one, you can zoom in nice and easy. Say you want to see where R714 goes, you can put little dots on it, press down to transfer through the board. You can see then this is the copper. So you can see it goes to that pin. The other side goes down through this trace, through around, down to here. So you can just put a marker so you don't get lost. Follow it through, down into this pin here. And then you can all go through the board to vias to the other side and literally follow your way through, basically. And that's how you'd reverse engineer. You'd take a lot of time, just like we're doing on this, to slowly work through the board and layers and put pin to pin, and then that's how you'll form the schematic. That combined with this bill of materials we're making that will also be shared, will make this into a complete schematic at some point. Part kits, I could make a part kit, yeah. So I'll probably sell the boards blank, the boards with the part kit, or the boards fully assembled with the parts on, and we'll just do like 3 selections in the options when I've done this. Right, so next up, where are we? We've got C201 to transfer over. That's next. And then I don't know where to put. I'll probably put the other. Yeah, I don't know what to do about the transistor. I want to almost skip ahead. What I'm going to do is put every component on that we can quickly identify: resistors, caps, inductors, transistors. And I think at the end of the stream, then we'll roll back to all the complicated chips like Q504, because I don't want to spend all my time doing that side. It'll be fairly boring for you guys. We'll try and get majority of this work done, because I do want to see this getting to somewhere near completion. Not like I want it to be complete today, basically. These now, I'm going to put these 2 connectors on, and I'm just going to do that the easy way with... actually, no, we won't, because that's got to go on yet, and I don't want to melt that one. So I'll put this one on down here, because this is far enough out of the way. And then we'll move up to the other top of the board. So flux on there. And the easy way I do it is basically to hover it over my desk. So I guess you can kind of see. Do that, and I'm just going to do it here. Like, whoa, that's zoomy. Get it like that. There you go, so you can kind of see. That's what I'm going to do. And this is all to do when I solder them on. I kind of hover them over the edge. Place it on there. And then do this. So this is how I typically work at the minute. To be honest, that's it's almost a better view than you had before, but you can't see the pins, so you just have to bear with me on this one. Tastes when it doesn't melt your fingernail as well. Much easier this way. Nearly there. This will probably pull it now. Yes, of course it does. This one pulls nicely when it wasn't easy for you to see the pull. I don't know whether you saw that on there, the jump, but that was the pins pulling into position. And then it cools down again once it lands, and now it's about to fully reflow. There we go. So So that goes to the overhead now. We bring that in. You can see that's nicely reflowed, and it's still warm, so if I put some extra flux on now, you'll see that normally if it's hot enough will bubble, there you go, and reflow them pins even nicer. Complete Xbox OG cap kit. I'll pull it on my list. We've got another one in. I think we've actually just finished all the Xbox OGs. I don't think there's any in now. Next one I do, I'll make the kit. I've been saying it for ages. Let me just correct this camera view as well now. So when I swap back, we've actually got the correct view. There we go. PS5 diagram on the website. No, I don't work on the modern stuff that much, just mainly HDMI swaps. So nothing massive on the PS5. I think I did some Xbox Series X and S reverse engineering at some point last year, and that's all on the wiki. But no, PS5, I'm not really a PlayStation fan, I'm an Xbox fan, so I don't really work on PlayStation much, other than PS1 is obviously one of my favourite consoles, but after the PS1, not a fan of the rest. So we're going to leave that because of the heat, we're going to leave that because it's complicated and come back, and I'm going to check on the bill of materials, did we write everything down? Because if we didn't, yes we did, so that's fine. Right, so now it's this area and we're done. So let's start with everything that is easy in a sense. So resistors, caps. Let's start with all the resistors. So let's see if we can find all the resistors and do them all in one big go. R507, so I'm going to write these down at the same time as pre-tinning the pads. We have R508, which is here. R504, which is there. So R508, R504. We have capacitor there, diode there, capacitor there, resistor here. So R505. R507. And then we have, I'll tell you what, let's do it in that small chunk. I think we said this last time. I go for do loads and then I decide we'll do it in a bit smaller chunks. 222 should be 200 and, no, 2.2K. Yeah, 2.2K this should be. Go on, multimeter. Yep, 2.2K. So 507 is 2.2K. 505 is 391, is that? So 390, I'm going to guess. Yep, 390. So 505 is 390. 508 above it. 508, 103, that should be 10K. Yep, it is. 508 is 10K. How do you know if you're changing a resistor or a cap? Visually. So resistors are most commonly black with writing on, or green with writing on. Caps are much thicker. So if you looked at the board from here, from the side, see how thick this cap is here. See how much it's standing off the board. And look at the resistors that are flat. So caps are usually sticking up more. You can see this one isn't. This one's fairly flat. But the colour's also a good indicator. So again, fairly common now, but capacitors are normally this brownish colour. Resistors are normally black or green. Inductors can confuse people because if we look at inductors on here, pull focus a bit. Inductors are in between the two, so they look almost like a resistor with the colour and a capacitor with the thickness and size. So inductors can get confused for capacitors. The other helper is, you can see the board literally says AL and then an indicator. So AL is for inductors, C is for resistors, R is for, C is for capacitors, R is for resistors. So a bunch of hints and clues basically as to what we're working on is in just knowing what you're looking at really. We're working on a PC Engine GT at the minute, a handheld PC Engine, and we're just identifying all these components. Our 504 is 100k, I presume, based on the number. Yep, so our 504, 100k, and then we have our 507, which is 2.2k. Oh, I wrote our 507 twice. 507, 508, 504, 505. Yeah, because there's only 4 resistors, I just wrote it down twice. So now we know all them are good. We can swap them over. Put a little bit of flux on. I'm just going to hot air these, move these out of the way, and I'm going to hot air them one at a time down onto this board. So if we just put something under here a minute to bridge it up so it's not reflecting. There we go. And we'll transfer these over. Yeah, ask away if you've got any questions. Start with our 507. Hey, thanks. I'm glad you like the style. I just noticed that comment I've missed. Glad you're liking what I do. It is nice to know people appreciate it, because when you do it for free so long, and you know, you do question whether people are actually appreciative of what you do, and you know, you question why you give stuff away for free, even though that's naturally what I always want to do. I love giving knowledge away. It does get to the point sometimes where you wonder and you think, oh, should I charge for stuff? Because at the end of the day, we all need to make money. But I do like to keep everything as free as possible in terms of knowledge. I don't like to charge for knowledge. I don't mind charging for labour, but knowledge I love to give away. I think it's people then that don't have money aren't limited by what they can learn just based on if they can afford to learn. I think that one's got a tiny bit too much solder on, so that one keeps wanting to move off centre. Same with this one. So that's going to be fun trying to nudge them too. I'll probably touch them up with an iron because they're not wanting to stay flat. What lenses for this camera and stuff, the overview. It is a Blackmagic Cinema. Well, this is a Pocket Studio 4K, I think. It's 6K at the minute, so a 6K sensor. Downscaled to... that one's really doing me head in. It doesn't want to sit level. Not important, I just want to get it nice and straight. It's basically like cinema grade lenses and equipment just to record a 1K stream. So overkill, but I love the quality. And it's something I've built up over the years of buying parts, and I got quite heavy into the whole videography stuff, basically. It doesn't matter for resistors, they're not polarized. Same with most capacitors except the electrolytics. So it doesn't matter. I'm not very pleased with those. They don't look very well. Like visually they aren't as pleasing as the others, but I don't want to waste time doing that. Right, caps in this area, we're going to do all the caps. So let's write down all the caps as we go. This is going to be C721, C722. I'll show you the lenses in a minute, the Cameron lenses. I'll swing them up so you can see. It's C507, C505, Yeah, BGA work, I do it all the time. Hand soldering prototypes, often I use BGA stuff. So like the GBA clean screens, BGA chips, I hand solder them. If there's repairs I need to do, I will as well. I haven't done stuff in a little while. We don't seem to have actually seen much BGA stuff in. We've been flooded with stuff like this, but yeah, I've done plenty of it. Right, that's them pads tinned. I'll just show you this camera now. So the face cam here is an OBSBot. So that's ridiculously short for the price of it. Like, I can't tell you how good that lens is for a cheap, small, like £300 camera. This one I'm zooming around with is another OBSBot, so this isn't that clear. You can kind of see it's okay, but it's far from sort of, ooh, all the flux has run. Look at that dirty flux on the other side. Right, there. So you can see it's clear enough, but not as clear as the overhead. So I can see the lack of pixels basically in the image. But that's still really good. That's like a £2,000 camera, maybe. Can't remember what I paid for it. Or £1,000, I don't know. That's that one. And then the main one I've got for the overhead, which is the super clear, is, why is that so zoomed in? There we go. Zoom out. You'll see the jerry rig of a setup up here. So go up here, got a big frame on the table. Just clamp some arms to it now so I can move it around. And then this is the Blackmagic 6K cinema camera and a Canon cinema lens, so the cinema glass, which is much higher grade. I've got this electronic zoom that comes out, and you can see I've attached a USB cable inside the circuit board, brought it all the way down here, down the arm, wrapped it up, and I've got a little, can we see that anywhere? Where are we? There we go. I've got this little switch, so I can flick that switch on and off to zoom in and out. This is the pull focus, so this is what you'd normally attach to your cinema rig to focus. So then if I hold this board here and I'm twisting the focus, you can see I'm manually pulling focus basically when we're working. So I'll put the board down, and then this is me pulling focus. It's not autofocus. Again, you wouldn't normally autofocus in production, like talking main production studios and cinemas and all stuff like that. You don't have autofocus. It's not a thing. So you get used to pulling focus. It gives you more control as well. So that's the quick setup anyway of the cameras. But yeah, they're that good quality. I literally solder off them now. I don't even use the microscope when I'm streaming. I just zoom in close and use the camera. There's a slight delay, but not much, so I can live with it basically. Right, these caps we need to identify. So now we're going to move them all over, shunt them all to the side, so we can. Oh, why is my face super zoomed? It's done that OBSBot screw up thing. Let me just fix that. You don't want to be looking that close at my face the whole time. Let me just turn him off, turn him back on, see if that fixes it. Nope, we've got super zoom face. Let me open the OBSBot app, and if it ever opens, it should find, I think, both devices. Right, is this? Why does it tell me what camera it is? Yeah, that's this camera. So how do I tell it to not zoom in on my face so much? There we go. That's right, isn't it? I think, yeah, one. Was I a bit more zoomed out? I think I've got it set to slightly cropped in. I can't remember. 1.1, there we go, that'll do. Yeah, it does that every now and then, just randomly glitches, and it rarely does it, but randomly glitches and zooms super close to the face. Right then, let's move these caps off, measure them, get them transplanted. And you're moving them off to the side because you don't want the board interfering with the measurements. If they're in circuit, then the rest of the circuit can affect what measurements you're taking. So we nudge them over so only one pad's touching to keep them in place, and one pad touching can't affect the circuit because it's only from this side out basically. So if you're wondering why we're moving components off but not all the way off, that's why. C503. Right, that's all them. Now we get the LCR meter in and move him back into place. The other good thing with this is you can store, if I press a button, you can store set positions like that. So that was the last position we must have saved. So you can kind of pre-configure the setup if you wanted a certain position on, say like there now, I can hold a button, save that position. Then we can do another position that's maybe, say, zoomed down here. And save that as like position 2. And now what I can do, I can just tap button 1 and it'll move over and go back to position 1, and I can tap button 2 and it would move back to position 2. So you can kind of set up positions pre-recording if you wanted to. Yeah, you have to be careful not to pull traces, that's for sure. Right, C721 we'll do first. And this is 428 rather, nanofarad. So 430 nanofarad. Closest one to that is 470. So I'm going to say it's a standard 470 nanofarad. Then we have C722. 1.5 nanofarad. So 1200 pica is 1.5 nano. Caps lock's gone on, I think. There we go. Then C507 is still on the board. We didn't move that out of the way. Let's move him out of the way. That beeping's my eye and constantly dying because it knows I'm about to replace it. We'll come back to 507 because I've just moved it and I want it cool down. So we'll try 503. Is 31 nanofarad. So 31, closest to 31 nano is 33 nanofarad. So let's go with 33 for 503. 33 nanofarad. We'll go back now to 507. That should have cooled. That's 30 nanofarads. That's going to be 33 nanofarad as well. And then 505 is going to be 370 nanofarad. The closest to 370 is 390, so that's going to be a 390 nanofarad. So that's them done. Now we can move them over. How do you get better at finding shorts? All depends on techniques and things. Normally, obviously, the first sign if you have a general short is your power. If you're using a bench power supply, you will see a massive increase in current based on a known working board. So you'd have to know what to expect, because if you don't know what the circuit would typically pull, you don't know what is classed as a short. So you have to kind of identify that first. And then once you've done that, if you know there's a short and it's pulling, you ideally want a thermal camera to start with. Thermal camera will show most things, but it won't show dead short. So the irony is, if you have, this is something that took me a while to figure out. If you have a complete dead short at 0 ohms, then you won't even see heat. So if I soldered these two pads together and turned the system on, you'd have a dead short to the 5-volt rail, but you'd have no heat whatsoever in this area because there's no resistance there, so you can't generate heat. So instead, the trace going all the way through the circuit, your power supply and everything else would be warming up, but the actual part where the short is wouldn't. So that's your worst kind of short. That's a dead short. That's literally a 0 ohm short. They're hard to find. You pretty much got to rely on your eyes at that point to find the short, which can be a nightmare. But a lot of other shorts, you'll get a tiny bit of resistance. Or if there's a short inside of a chip, like this chip, the chip's package, the epoxy resin, this black stuff will heat up because the short's inside and it's not fully 0 ohm. So the bond wires that are thin go in and then spread out to a thicker die, and the bond wires are what you'll warm the chip up a bit as well. But most shorts, most failures, you'll have a little bit of resistance. They won't be dead shorts. They'll have 1 ohm or 2 ohm resistance. If they have, then that actual thing will get hot. So if you have a cap that fails, and it's shorting, it's not normally a dead short cap. People will say it's a dead short, but it's not. It's just a short. So the cap will literally get hot. So it's easy to find shorts that are not dead because you can just look for heat, spray IPA on the board, look for where it evaporates, things like that. But other shorts that are literally complete 0 ohms, very hard. This is a quick 861DW hot air station. Microscope for beginners depends on your budget, but I'd go with Amscope, AM Scope. They are, you get a lot for your money basically. I had Brunel microscopes, and I probably want at some point like a, when I burnt my finger that hurts. I had like I want rather like the more expensive branded microscopes at some point, but I had a Brunel and it was no better than an Amscope. So I don't know how much better quality the optics are going to be in the higher end microscopes, but if you bear in mind this camera is all about the optics, so the glass is the reason and the CCD sensor are the reason this image is so sharp. This is a 1K image that beats any 4K camera that you'll see on the market. This is just, a 1K from a Blackmagic sensor, so sensor quality and glass quality really do make a difference. So that's why I'm kind of thinking high-end microscopes probably would definitely make a difference. But yeah, AM scope is what I'd start with. If you haven't got the budget for an AM scope, then you're stuck with USB microscopes, really. But you get no depth perception. So how I'm soldering now, there's no depth perception on this. I can't tell where, say, my tweezers are now from the height of the board. Not got a clue. So I just feel when it's touching. I've kind of got used to working like this now, though, because of doing the streams. But yeah, you can't beat a bit of depth perception. It's a lot easier. I think I've developed this new skill to not have depth perception when I'm soldering, so that's what I've got good at. Right, D501 we might as well do next. That's a diode, so that will use the multimeter. Bring this in. So this diode could be, we go nice and close. I think we're fully zoomed in. There we go. So this D501 could be 1 or 2 diodes. I'm just going to use my multimeter and then go into diode mode. Diode mode should beep when you touch things together. So if there's a dead short, in a sense, that you're expecting a diode but it's shorted together, it's physically connected, you get a permanent beep. If it's a diode and you find the right orientation, let's test this way. Hear that single beep? That single beep means I've found a diode. So this is the cathode, this is the anode. If I look at the multimeter, it says 0.56 volts. So we've got an anode to cathode, a cathode here, an anode here. So if we check the third pin, do we have also a diode? There we do. So we've got, again, a fairly common cathode to double diode, which I keep binning it and I haven't got it on my desk, so I have to bury it out. We zoom out. What we have is this, exactly the same again. So there's the chip, flip it round. We've got here, this pin is a shared cathode, the negative. So both of them negatives connect here. And this is the anode to 2 different diodes. So that's what we're looking at in terms of what this is. So I can copy that, D501, the description, from the other diodes that we've written, that most of them are that. So anode is 1, cathode is 2, so it's not that one. There we go, dual diode, anode 1, 2 cathodes on 2, anode on 3. Right, paste that in. So we can transfer him over, but while we're here, let's test the other diodes if there are one. ZD will be a Zener diode, so which one is that pointing at? So that's going to be a Zener. It says 6.2H, so that's probably a 6.2 Zener diode. D503 then, let's test if this is the same. So we're going to presume cathode, anode yes, same again. So D503 is identical. Any particular model for the Amscope? No, but all I'd say is on these, so when you're looking for a scope, I think this is an Amscope as well on here, this white part, look for the ones where these are adjustable like this, movable. If you get ones where these still move, but they're just tubes, straight tubes into the body, and it's just the tubes moving, I find the optics of that, well, it's what Zach uses, and I find it impossible to use. So, oh no, he's changed. Yeah, that's a point. That one, I was just about to say, Zach's got hard to see. His is still hard to see, but he's got ones that look similar. But I tend to find the ones that move like this are better than the ones where it looks just like a tube going into the body that move. Some of them can be crazy hard to see through, and I just can't use them. Which I've got a bunch up there, I think. Yeah, so 1 second, I've got one up here if I can get it. So this is the one you do not want, hence why it's up there. So this one, impossible to see through. See how they move left and right? I cannot for the life of me see through these. They don't focus right. So avoid ones that look like that. But to be honest, I think all the Amscopes that look like this, you're fine with. Right, what were we doing? This board belongs to this PC Engine GT, our customers. We're just fixing up. At the minute, we're mainly identifying all the components on the board. That's the job we're on at the minute, is component identification. Oh yeah, we were writing down D503, weren't we? So we were identifying this component. It's identical to D501, so I'm going to copy and paste that. D503. Any other diodes? Got transistor, 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 transistor. Diode there, D900 and D901. So we've got two here. We can see if they're the same again. We have, so far the pattern has been, we've always had the cathode here and the anode here, same again. Yep, so that's identical. This one, yeah. So every diode there is exactly the same. So that's made our lives a little bit quicker. Paste two of them, write down D900 and D901. So that's all the diodes left on the board. Let's transfer all them over. So we will just get this board, pre-tin the diodes, diode there, and then two diodes up the top somewhere. Where were the others? One up there and one there. So a bit of solder on that. Solder on that. Solder on them. We've already got solder on that one, so that's it. We will then hot air these off. It doesn't matter which way they go now because they're all the same, as long as we take the right components off. You can see how much quicker the second one flows on as well once the board's warm. Hey, thanks. Glad you like the bit of reflowing. Temp on that was probably 480. Yep, 480 degrees Celsius, 80% airspeed. But you can reflow at almost any temp and speed, so I wouldn't focus too much on the temps. More about the technique. Find out what works for you. But if you're unsure and you want to follow something, I always say pretty much 480 degrees Celsius, 80% airspeed. You're safe on most things other than really old fragile Ataris. Basically, you should be good. Oh, the drinks aren't good tonight. Cold tea and these stupid drinks I brought. So, of course, I brought 12 of them. Now I've got to drink them. So, nobody likes them. I've given the missus, she hates them. The kids don't like them. They look ace, look really good, but they taste disgusting. But I've paid for them, so I'm drinking them. But, yeah, not good. Do not taste good. Right, so just going to clean my desk again just because it's getting a little bit tacky with the flux. Oh, I did order some stuff as well. I ordered some blue kitchen fabricy towels as well. I was going to start putting down to try and stop the flux gain on the board. Somebody recommended something similar, and then I went B&M the other day and saw the blue rags and thought that I'll try. What I was going to do is put like the blue rags down here while I'm soldering and just keep replacing them, so we don't get the silicon covered in flux all the time. But I forgot. There we go, a bit cleaner. Boot up and shut down. Are you JTagging it, or you just try and get it working for the 360? Right, so what are we on next? We're going to leave this queue because it's 5-pin. Not sure what that's going to be yet. It'll obviously be some form of transistor setup. We'll do all the caps now, I think, like the remaining caps. We'll leave the queues, leave the Zener, or to be honest, ZD500. It's going to be a Zener diode, and it's got 6.2H written on. Let me see if I can find anything on. I'm going to look on the other, like other circuits that use a similar setup. See if I can find any justification, because it's similar to the Atari Lynx power circuit, where it's going to be using a Zener diode and some feedback to set the voltage for the 5-volt output. I can test it more thoroughly by actually passing a limited current through it and stuff, but for now, let me just see if I can find anything about that part number. And Zener diodes are notoriously hard to test because they don't work the way you think, in a way. You think you just put a resistor in, turn them on, and they set a voltage, but they don't always work that way. They're quite inaccurate. So when I was making the Atari power repair kit and redesigning their circuit, the Zener diodes, I'd buy them from 5 different manufacturers, say a 4.7 Zener diode or something like that. And one would be 4.5, one would be 4.3, one would be 5.2. They're not super accurate. So I'm going to leave that one on for now, and I'll do a proper jig setup to figure that one out. So I'm going to leave him. Al500, just an inductor. We can measure him, so let's get him over. I think we'll do the inductor, then we'll just do all the caps that are left for now. Get them all over. And then we'll come back to the complicated stuff after. I think we've inadvertently left the worst till last. Like, this area is just full of transistors and components that are hard to test. Finish all the remaining resistors. Absolutely no reason. Shall we just do that first so it's a bit more systematic? I'll test this inductor now he's on the side. But the only point in this is to filter the backlight circuit, so the value here isn't that critical for any reason. Right, so that is struggling to identify whether it's an inductor, so we'll set it to inductor mode, go back on, see what it says, and it could be a ferrite bead, but I'm pretty sure it's going to be an inductor. So 15 microhenry inductor, which would kind of make sense. So we're going to put that down for now, and again, not a critical component because it's just filtering the backlight circuit, so we can always respec that, and I'll probably spec it better than original anyway. So that's just going to be 15 microhenry inductor. Move him over, and then we'll do the resistors next. Then we'll finish off all the resistors. What we're doing, we're transferring all the components off of a PC Engine GT onto a board I've remade, and then measuring all the values of the components as we go. With the idea being then I can get the factory that make these circuit boards for me, pre-assemble all these components so it doesn't take as long when we're swapping components over. I go live most days, absolutely no schedule at the minute. You'll normally find me on at 5:30 or 6 in the morning UK time, except Mondays because orders are crazy on Mondays. But generally I go on most days at the minute, but there's absolutely no schedule. It's something I should probably try and do, but I'm not the best at schedules at all. I don't plan tomorrow, so planning lives is pretty hard. Let that cool a minute. But I'd say the most common times I come on is usually early morning, like 6ish in the morning. And then about this time, 3, 4 in the afternoon, maybe 6 in the afternoon sometimes, just for a bit of unwinding sometimes, just do some work. If I knock off too early, the night's too long and I get bored. What degree do you need? None. I'm self-taught in everything. I've got no education whatsoever, and I do it for a living, so you don't need any, basically. Right, we'll write down all of these numbers now in the spreadsheet. So we have R501, R500, R901. Yeah, RetroSex is me. RetroSex is the other business. That's I'm not involved in that one. R900 and 901. Where did I learn it? I taught myself. So literally buy Game Boys, buy hardware, try build hardware. It's not something you just learn, overnight. It's just all built up knowledge from years. So pretty hard to kind of say how and where, but like, for example, now the things we're learning here are new. When I worked on like a Apple Mac recently, I know absolutely nothing about the Apple Mac SEs. I streamed that. It was one of the first streams. That was me learning how the thing worked, so you can kind of watch what I do there and see how I learned it. But anything that comes on the channel that I don't know, you'll just see me working through it the way I would. That if I don't know something, you'll kind of see how I figure it out. 905, right, that's all the resistors. So we'll go back up to the top, measure them all, and see if they're right. So this one looks like 680. Let's measure that. Oh. Go on there. Multimeter is in diode mode still. Let's go back to resistor. 72, so that is going to be 68. Oh, they taste disgusting. Don't put them in your mouth. 68R. 682 is 6.8K. We've had this set up before. Yep, 6.8K. That's 500, yes. Hey, welcome in from Uganda. Can I replicate any board? Mostly, yeah. Circuit board wise, certainly. Electronics wise, depends what it's doing. 901 is 472, so that's 47 and 2 zeros, 4.7k. Where's it gone? There. Yep, 4.7k. Moving down, we have R900, so that looks like 472 as well, so probably 4.7k. Yep, 4.7k on that. Then 514 looks like 473, so that'll be 47k. Yep, 47k. Printing traces, I'll send them to mass production, to actual PCB factories. I used to make them myself at some point, but I don't anymore. 904 we've actually missed on the list. On 904 is the sneaky one upright. I can't see what that writing says. 3 something, so let's just measure. 3.6k, I think that'll be. Yeah, 362, so that'll be 3.6k. Uh, 509 is here. 682 will be 6.8k. Nope. That'll be in circuit then, because it's 3.4, so we're going to have to nudge them out of the way. It's probably going to be in parallel. These two 6.8ks will be in parallel with each other and forming a divider, which I'm not sure why they're doing that. Why don't they just use a 3.4? Maybe they didn't have a 3.4k resistor at the time, because I've seen that somewhere else on the board. So this one is almost definitely going to be in parallel with that. So now these will probably measure out of circuit correct on both of them. Yep, 6.8k. 6.8k, so 509 and 516 are 6.8k. 903 is here. 123 is 12k. Yep. Bulk of the work is probably prestige consoles more than repairs. So we build, like, people buy pre-made consoles. They're by far the most popular. We do them every single day. But I don't normally build them. Like I say, Zach does a lot of that. So this looks like 913, 91k. That says 49k. Oh, no, it doesn't. Yeah, it says 913, that does. So we're going to have to move that out of circuit because something's in line with that, causing it to drop, I'd say. 902 or 903? We've done 903, yeah, 902. And now let's see if that measures what we expect. So I'm expecting 93k. Yeah, 93k. And then 905 is apparently the last one, which it is, down here. That says 103, so that'll be 10k. And it is. So that's all the resistors measured and they're all working. So let's get them all moved over to the board. Then we'll do all the caps. And then we're nearly there. So flux on the board, just to clean them as we're taking them off, because they've got a little bit of electrolyte on them. And our board, did we tin all the resistor pads? We did not. So let's tin all the resistor pads now. 507's on. It's going to take just as long to find the pads now. R500 is this one here. R901 is there. R900 is there. 514 is there. Or 904 there. 903 there. 902 below it. This is, yeah, both resistors there. 909, 916, and 905. That's all the pads tinned. Now flux on them. It'll also help me identify where they are, because when you're looking at a bunch of pads, it's hard to see where they are. There we go. And now NF flux, don't recall trying it now, but I've tried every flux available on DigiKey and multiple other places. I tend to try and find flux that is also fairly mainstream and also easy to source, because you tend to find half the time you'll get a flux, like when I used to use Amtex, and then you can't get hold of a genuine source. They always end up going out of stock. So the Styr is that good, I don't even look around anymore. That's become the number one flux for me to go to. Oh, we didn't tin one of the pads. The first one we're about to do, we didn't tin. Right next to it. That one there. What app am I using? What, for the stream? Using Streamlabs. And then all the integration stuff, most of it's Streamlabs, and the TikTok stuff is Tickfinity, it's called. This as well, this backlight enable, this BLH. You short that if you're using the original backlight, but the customer's actually having a screen upgrade, so we're not going to re-short that, because we would technically remove that short if we were doing the IPS upgrade, so we're actually going to leave that disconnected. Tried Jasper, tried getting RGH with a resistor diode, and tried booting 10, and it's the same thing both times. That's literally I've got one exactly the same. You know, when I said I've got one where it's I turned the power off, like pulled the power instead of using the power button at the point of doing in the RGH and reading the keys. Whatever caused it, I haven't found a way myself to bring it back alive. I've got a feeling the eMMC is just corrupt in a way that the part of the system that runs the initial code gets confused by the eMMC. I'd say my next step, if I was going to try and diagnose that, would be to remove the eMMC so it can't interfere, to see if you can get it to JTAG, and then probably plonk the eMMC back on while it's JTAGed, or wipe the eMMC with an external reader. That'd be like my guess if I was still working on that one. But it might be worth just cutting your losses on that one for now, time-wise. One more. it. So I think that's every resistor on the board now. Yeah, so you've seen it a few times. It's it'd be good to figure out what it is. But I'd say it's got to be, well, at least the one I did, it was definitely related to, it was working, I wrote the cell, and then during a power cycle, it no longer would JTAG. So something gets involved in the steps. If you've not even got to the point of trying any form of manipulation on the MMC yet, it might be something else, but I'm guessing if you've touched the MMC at all, and then it's just randomly failed, it's going to have something to do with, obviously, tweaking the MMC and it failing. I think it's like writing an incorrect bit at some point, and that's it. If it's corrupt, it screws it up. There should be a way to recover them. We just don't know of it yet. How can you work where we work? We don't employ at the minute. We're pretty much a family-run business now. But nothing stopping you getting into the retro modding yourself and chucking some consoles on eBay and that. PCBs, especially the ones we make, are very heat resistant. They can take a lot of abuse. Yeah, you pretty much got it crashing then exactly where I've got it crashing, which is as soon as you've written the cell and then something fails. So it's definitely related to that cell. I think it's just writing the cell wrong. So I'd probably make sure your wires are nice and short, all the ones to the Pico or whatever you're using to do it. Make sure them wires are nice and clean and short, because that is going to be causing you. I think it's basically writing incorrect data, because if the wires are too long or getting mixed up. So I reckon that's what's causing it. Q502 is easy to identify. That not so much. The Zenodiode not so much. That not so much. These transistors, this, and this, the 3-pin transistors, are easy enough to identify. But let's just swap all the caps for now. Let's start with that, or identify them. So again, maybe do all the caps in one go. Slant them to the side, measure them all in one go, and then transfer them all in one go. That seemed to work good. Nudge over. Nudge over, and then we need to write down all the caps before we move them, so don't forget to write down the values. My iron is 390C. Yeah, where's that gone? Stuck to my iron. Get off. Nearly lost that one then. Put in there. That's right, I think I've Turned everyone. Yep, there's none left down here, so I think that's all of them. Time to measure. My boards are, yeah, should be FR4 standard, so just fiberglass basically. Hardest thing I've ever soldered. Trying to think really. Nothing's that hard to solder anymore, so it's like I don't know, to be honest. It sounds a bit thingy to say, but nothing's actually that hard to solder. I'd say the hardest thing to solder these days is if your PCB is not in great shape, or the board you're working on is not in great shape. That's harder than soldering, say, you know, a CPU with 1,000 BGA pins. That's just technique. Things like the Dreamcast, Sega Naomi's, the arcade boards, reflowing the, or completely reballing and replacing like the Dreamcast BGA VDPs. They were difficult until I got the technique right. They take time and technique. So that was hard to get them right, and you have to make sure your board's totally flat and's got no warping. There's just like a lot of technique to BGA soldering if you're going to do it by hot air, not machine. So BGAs are definitely hard when they get big, but I don't know, it's not as hard as you think, basically, I guess, as the answer to that. Soldering isn't that hard. You just build up some techniques. It's more learning the techniques that work that's the hardest. Especially as you work on different things. Things are, you know, boards that you think could feel or work the same as others, you find out they don't behave the same, and you can have trouble when, you know, because every board can be slightly different. Right, so 350 nanofarad. Let's go back to our sheet. 390 nanofarad, that's going to be then. And that is C713, 390 nanofarad, I believe I said. 713. Yep. 714 next. .5 nano again, very common on this board. C706 and C716 will be next. C706 is 220 pica, so 220 as a value for 220 pica, so could be exactly that. It could also be measuring slightly under and be 250 pica. I'm going to go with 220 pica for now, though. 716. .5 picofarad. There we go. 1.5 nano. It's a good job I waited. 1.5 nanofarad again. That could have been a really wrong measurement then. Now we have them four done. How do we work this so we don't miss one? We'll start over here and work our way up. So we'll start at the bottom this time. C903, C902. That is 100 nano, so 0.1 micro. You'd typically hold that. You wouldn't normally put 100 nano, but I'll put a 100 nano for now. And C902. That is 10 nanofarad. Don't know why it's showing up. No, 1 nanofarad. But it's showing us 1,000 peaks. That's 1 nanofarad there. 4902. Phone technician. Yeah, I watch some videos of people repairing the mobile phones, but it's not something I want to get into. It's like screen repairs and different variations of phones and far too much stock. I'd have to carry so much stock for that. ENIG I'd always go with 100% of the time. This board is pre-tinned. The one I've got, this might be one of the first production tests I've got because I grabbed it from down the corner. But I produce all the boards with ENIG. It stops corrosion, makes flowing solder much easier as well. I'd never not use ENIG. A hassle is not going to last. Well, it might, but no, I'd just go with ENIG. It's not worth the price difference. Right, so we've done 902. Next up is 904 and 900. C904, C900. $110 nano, which is 120 probably. So that'll be 120 nanofarad on 904. Yeah, and now 900. This is quite fluxed up. Let's just give that a bit of a clean. Uh, 10 nano, just over. So it's probably going to be 10 nano. It could be 15 or 12. But it's just over 10. So that's probably 12 nanofarad, but it's not going to make a massive difference in this circuit. It's not. I don't think it's going to be 10 because it's slightly over. I'm going to go 12 nanofarad on that one. How much did I pay for the meter? The LCR meter, this thing, I think it's about 600 quid. Let me just see. Peak Tech 2170. Shopping. Oh, not that bad now. Or is that not the make? I know they're only like 250 quid now. 280, depends where you get them from. I'm sure I paid like 600 odd pounds for this at the time, so that looks like it's come down in price now. C504 next. C504. One nano again. Ever so slightly over 1 nano's fine. C504's done. We now have C, and I've covered it with the cap. C500, 501, and 502. So C500, C501, C502, and that's all the caps done. GPS. You need to get GPS. They sell integrated pre-certified modules as well for all the GPS stuff. If you're going to make your own, you're talking £100,000 in certification, FCC certification. And I think for GPS, you have to register for something else. So I wouldn't make that yourself. I'd use an integrated package that drops into a chip and then talks to it over I2C or SPI. 13 nanofarad. Probably going to be 33 then. Well, there is a 30 nanofarad, but slightly over, so I'm going to go 33. 33 nanofarad. That was on the C500. Just double check that. Yeah, that's that. So 501. .9 nanofarad. So there is a 5 and there's a 5.6. Let's go 5 nanofarad. And then 502, the last one. Do you do many repairs on graphics cards? I missed that question. No, not really. I don't work on stuff mostly outside of retro now. We're that busy with the retro stuff. I don't like this measuring at 7 picofarads. Something's telling me that's not right. Just run out of. Ooh. I think that's just not measuring correct. Oh, I think it's touching a hole in the circuit board actually. Let's move 502 out the way a bit further. Measure again. Oh, that's floating now. I'll just swap that first. There we go. 1.1 nanofarad. So the fact it's slightly up, again, either I reckon it's slightly above the 1. So I reckon that's a 1.2 nanofarad. It, again, won't matter too much tolerance-wise, as long as you're in the ballpark. These will work fine on the circuit. So I think that's all then. Let's get to soldering. Jump over, go to here. So I've left that one floating. I'll do him first, C502. And we'll have to do the same again. We're going to have to tin all the pads and find where they are, because it's difficult to spot the pads. Now they're getting more filled, we should find them. So C502's there, 501's there, 500's there, none that side, C504's there, and then we have C900 there, C714 and 13 on the outside, C706 and 716 on the outside, 902 there. Any others I'm missing? 904 right there. (902), 903. I think that's it then. I think they're all pre-tinned. Let's get some flux on them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I missed that one. No, 11, 12. So that's 12 there. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 written down. So that's perfect. So that's all of them. More problems, PS5, 100% of the time. More problems in PlayStation in general. The amount we used to get in for, especially when they launched new ones, the PS5s, the HDMI ports aren't even soldered on from factory. They've fixed that now, but we used to be doing a PS5 every few days when we had the local store. Not good at all. It's been the same though. I used to build PS3 controllers, mod chips for them, rapid fire controllers. Sony used to release a new variant inside the controllers every 3 months, change up the connectors, change the positions for absolutely no reason. Made no sense whatsoever. They just constantly mess around with designs. They're always flex ribbons, which are poor connection. I've never really thought Sony's hardware designs are good. But obviously I'd say they're more popular than Xbox in general these days, but no, I'm much more. Since the PlayStation 1, I think they went downhill. PlayStation 2 was the most popular console for them. I think it still is, but no, I'm more of an Xbox fan myself, especially for quality side. Other than Xbox Elite controllers, they're shit. Microsoft really need to fix the controllers. They break, they stick drift within no time at all for no reason. They're not meant to last. The whole Elite controllers, unfortunately. The Elite 1s are actually better than the Elite 2s. Moving down to here. We've got the C900. The Elites, no, the Elites have got bog standard, not even Hall effect sensors. The Elite 1s and 2s, unless they've upgraded them recently. They're literally completely stock resistive thumbsticks. I think we've just got these 4 over here now, maybe. That's it. So I think with a second or two to cool, I think that's all the caps off. Yep, so we're now left with transistor, transistor, Zener diode, transistor, 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 transistor. So just all transistors, so it's going to be all component identification, basically. Some of them easy, some of them not so easy. And I didn't realise it was that late, 20 to 7. I'm going to get some tea, I think. So I reckon I probably would finish it tonight, but the fact that what we've got is easy to see on here. These 5 pins are going to be, and these 6 pins are going to be hard to figure out, so they're going to take some time. So I might do all the legwork of figuring out what chips these are off camera, just because it's going to be boring for you guys. We haven't got much left here, to be honest. We've just got the transistors. The transistors, we can identify the 3 pins in the component tester. Once we figure out which 1 5 pin is a certain thing, we'll probably be able to find the rest pretty fast. But there's literally a handful of transistors left, basically. So I'll either finish this, probably end up finishing it tomorrow, I'd say. But I'll probably do the legwork of identifying the components first, because there's not much interest there. I'm just going to be stumbling around, searching DigiKey, searching Google, typing in some queries, just trying to figure out what the components are, basically. That's not that interesting. Once this is done, though, once this is all connected, we've got to wait for this connector to come, wait for this pot here, the wheel, to come, because this connects to the cartridge port, and when you take them off, they basically melt. They're not designed to be taken off, and this was with light hot air as well. So I could probably get this working, like this connector, but it's just not worth the time to, you know, solder them pins on. I'm going to wait for the connector to come and make this a removable connector and convert this to a physical connector. So we've got like a ribbon that we can unplug. So we can't load games anyway until that comes. We're waiting for the wheel to come. So we'll, like, whether I finish this on stream, as in just putting them last few components on, I may or may not. It's just literally finishing them last few. And we can't power it up yet anyway until the other bits come. So I might just finish that off and wait until the other bits come. And then when the other bits come, I'll show you connecting this cartridge up and we'll attempt to boot this thing. But hopefully that will fully boot when we've got all the bits on, because obviously this originally didn't boot at all for the customer. No sounds, no audio, just no boot whatsoever. So I'm hoping that when we've done all this work, well, at least we know every component on there that's on there is good. I think we're going to get a successful boot, hopefully. Yes, it is a Stoke accent. Let's get this cleaned up. There we go. So that is now where we're at. Almost complete. And that's almost every single component identified now. Looks pretty nice. It's been a lot of work. Next one we get in, we'll have to see how quick I can do it when we're not measuring components. And we're just swapping over. But I'll try and see if I make a pack for this. This is the other thing. You imagine making a pack for this. There's that many different values of components in. I guess it's not that hard. Just put them in different bags. But even making the kit for this would be a bit of a pain. There's so many parts. But obviously, it's still better than having to use originals. But I think I'll still get the factory to assemble these for the most part. That's the best option. So it's pretty much assembled. We could put that connector on as well. Let's just chuck that connector on. So we've got that one connector. This wheel, can this wheel go on yet? The wheel can go on as well. So let's just, before wrapping up, let's put this wheel back on. There. I've got to clear the excess solder first. So we've got quite a bit of excess solder on when we remove this. And the problem with this wheel, luckily this isn't the one that was melted. You cannot source this wheel because it's backwards, basically. The pins on this are backwards and they no longer make them, and no factory is willing to make them in low volume. So luckily this wheel survived. Now we want to make sure when we put this on, there's definitely nothing in this area we need to hot air. And there isn't, as far as I can see. Let's just make absolutely sure that there's nothing around here. All them chips are on. That's the other wheel. That's the connectors there. Yeah, there's nothing we're hot airing anywhere near this area. But if we do come anywhere near this area, we want to make very certain I don't melt the living shit out of this connector like I did the other one, because I can't buy them. I'd have to make a little baby circuit board that sits over, or hand wire the pins from each pin all the way over. Them on. And there's the wheel pins. It's like it was always there. So that's that on, and then we now want to connect the high voltage. Again, this isn't going to be used, so it doesn't really matter, but we'll connect the high voltage connector back up. That way around. You can sit back down there. So I'll just hold that in midair in rough position like that. And then you'll get a dry joint doing this first because you're doing it one-handed. But I just blob solder on with one hand. See, that's all dry. But now with the other hand that you've now got free, because the connector's in and in the right position, which it is, you can solder this pin up correctly, let it cool, and then reflow the pin that was dry. And then I'm going to trim that down, even though that is stock, and that's the pins, that's how high they were. I'm going to just trim them flush now. That's it. We've been doing this for probably 12 hours, on and off. Basically, we're not just doing the work that's on here. So we have basically a PC Engine GT for a customer. come in with a broken board, so they wanted the PCB swap. So instead of just moving all the components over, what I've decided to finally do on this, because it's been something I've been wanting to do for a while, is every single component we've taken off this, like every single one out of the hundreds on this, we've taken off, measured with multimeters, component testers, and LCRs, and identified every single component on this board. So now we have a complete BOM of what every component is, pretty much. So it's taken ages because of that. We're basically done now. So there's a few bits that we've got to do, transistor-wise identifying, and then we're basically waiting for this cartridge connector to come now. So I'm just waiting on a ribbon connector that I can make this into an FBC connector on both ends, and we can plug this in. And then this wasn't working at all for the customer anyway. It was completely dead, so it may still not work, but my guess is it's going to work, because I think most of the damage is just trace damage and circuit damage on here. So I'm fairly confident we'll get this brought up straight away. But yeah, that's pretty much the finished article, and I like how it looks in white. And then we'll probably just get the customer messaging saying I actually wanted it in green, and then then we're screwed. I'll paint it green. So yeah, that's it for this one, guys. I'm gonna get some food, and I'll probably be on, almost definitely be on tomorrow, but it'll probably be either 5:30 in the morning doing something, or it will be probably similar time to this tomorrow.